This video goes over question 6 of the business optimization assignment. A parcel delivery service will deliver a package only if the length plus girth, distance around is the definition of girth, does not exceed 72 inches. Find the dimensions of a rectangular box with square ends that satisfy the delivery service's restriction and has maximum volume. What is the maximum volume? So we're going to need to put in the dimensions, and then a follow-on question will be to calculate the volume. And I've drawn a picture here, so we've got a square base and then a height. If I do the formula for the volume of a rectangular prism, it's going to be a function of 3 variables, length, width, and height. And that's going to be length times width times height. Now here, I have a square base, so that's going to be just a function of 2 variables, x and height, and that's going to be x squared times height. In this class, we're only going to do functions of 1 variable, so we're going to need to find a way to get rid of the h variable. And we can do that by this requirement here. The perimeter plus the height can't exceed 72 inches. So the perimeter of a square is 4 times the side length, so 4x plus height equals 72. So h equals 72 minus 4x. So I can rewrite this function only in the variable x as x squared times 72 minus 4x. Distributing out the x squared, I get 72x squared plus 4x cubed. And in calculus, if I want to maximize or minimize something that I have a function for, I'm going to take the derivative, set it equal to 0, and solve for x. So v prime of x is 144x plus 12x squared. I'm going to set that equal to 0. I can factor out a 12x from both of these terms. So 12x times 12 minus x equals 0. By the zero product principle, either x equals 0 or x equals 12. So I know that x equals 12. I still need to find the h dimension, and I'm going to get that here. So h is 72 minus 4 times 12, or 72 minus 48. So this is now a 12, so 12 minus, or actually, so 48, not 12 minus 8 is 4. This is now a 6. So h is 24. And I'm going to put those dimensions in as 12 by 12 by 24. I'm going to put that in. 12, 12, 24. Check answer. And the problem is this is a period, not a comma. 12, 12, 24. Excellent. Now it wants to know what is the volume. I'm going to go to the calculator to get that. And 12 times 12 times 24. So that's 3,456 cubic inches. 3,456. Check answer. Nice work. Now we're going to go on to the next part. So here's a sketch. The radius of the cylinder is blank inches. And then we're also going to have to figure out the maximum volume. So here's a picture. I've got a circular base, and the circumference is going to be 2 pi r. So the volume of a cylinder is going to have 2 variables, and the volume is going to be pi r squared times h. Once again, I need to get rid of the h variable. So I know that the girth, or the distance around, in this case it's going to be the circumference plus the height, has to be no more than 72 inches. So 2 pi r plus h equals 72. So h equals 72 minus 2 pi r. So now I can get this down to just a function of radius. So that's pi r squared times h, which is 72 minus 2 pi r. And I'm not even going to try to do that by hand. We're going to go straight to the calculator here. So I'm going to go to calculator, get back our work picture here, half screen that, and I can move over so I can see my function. I'm going to start a new problem, doc, 4 for insert, 1 for problem, and I'm going to actually use a calculator page. I'm going to do volume as a function of radius, and in the calculator page we're going to go control palette-o-math, and above the palette-o-math is this colon equals, that stands for is defined as. I'm going to go to the pi palette for my pi r squared, then parenthesis 72 minus 2 pi r. So it says done, and I'm going to go ahead and get the derivative of that, shift minus, now my variable, remember, is r, so I'm going to put in r, tab, v of r. So there's my derivative, menu 3, solve, grab my derivative, set it equal to 0, and solve for radius. And I get r equals 0, which would obviously not be the right one because that would give me 0 volume. So the radius is 24 over pi inches. We'll go put that in. Fraction 24 over, and they give us a pi here. We'll check that answer. Well done. So now the height of the cylinder is, and we can figure that out because we know that height is 72 inches minus 2 pi r. We'll go to the calculator for that, and we know that r is 24 over pi. So it's 72 minus 2 pi. I'm going to grab that. I'm going to put a times and then grab this. Control, copy, go back down here, put that in, and I get 24. So we'll put that into the book, 24 inches, which is the same thing we got for the height when we were doing a square base. So fantastic. And now we need to get the volume. And we actually have a volume function here. It's volume as a function of radius, and our radius is 24 over pi. And it says round to the nearest cubic inches needed, so I'm going to put in a decimal point and put in the pi. So I get 4,400 cubic inches. 4,400. Check answer. Fantastic. That concludes this video.